When the polynomial below is divided by x plus 3, the remainder is 0. What is the value of the polynomial's constant term? So by definition, if we're dividing by x plus 3 and the remainder is 0, that means x plus 3 is a factor, a perfect factor of this problem, meaning it divides into it evenly. But also more importantly, it means if we set x plus 3 equal to 0 and solve for x, and you can probably do this without showing the work, this means negative 3, x equals negative 3 is a root of this expression right here. And if it is a root, if x equals negative 3 is a root of this polynomial, that means when we substitute negative 3 for x, it should yield us an answer of 0. So what I'm going to do is I'm going to rewrite the original problem, I'm going to rewrite this here, but I'm going to replace everywhere I see an x with the root of negative 3. And then plus empty box. We know this empty box represents the constant term. The constant term is just a number that does not have a variable in it, so the negative 3 won't factor in. But we know all of this should end up equaling 0. We could use a calculator, but I'm going to do old school mental math. Negative 3 raised to the third power, that's just negative 3 times negative 3 times negative 3, and that is negative 27. 3 times negative 27 is negative 81. So I've taken care of this part of the problem. Second part of the problem, negative 3 squared is positive 9. And negative 5 times positive 9 is negative 45. And then finally, negative 40, cross that out, negative 47 times negative 3. See, negative 50 times negative 3 is negative 150. So that should be positive 141. I'm going to pause and check in my calculator. Yeah, that should be right, but I didn't want to lie and say I didn't use the calculator here. Plus something equals 0. So negative 81 minus 145 plus 141. Let's go and use the calculator for this as well. Negative 81 minus 45 plus 141 gives us 15. So then 15 plus what gives us 0? Well, it's got to be negative 15. It's got to be our answer. So negative 15 is the missing constant term in this problem.